All right, let's go over some different question types that you'll encounter. The first one is what is, or find, the nth term. So 10th term, 20th term, millionth term. This is asking you to determine the value of t subscript n. So in this first example, the perimeter of an equilateral triangle can be represented using the equation p equals 3n. So p in this case could be t sub n, where n represents the side length. Determine t30 and t50. Basically, this is asking you to find the perimeter of an equilateral triangle with side length 30, and this is asking you to find the perimeter of an equilateral triangle with side length 50. From the top of the page, we know that if we have an exponent of 1 on n, then we are going to end up with a linear function, right? And that linear function is the same as an arithmetic sequence. So let's find t30. All we need to do is plug in 30 for n, 90. t50, plug in 50 for n, 150. In the next example, find the first 3 terms in the sequence described by tn equals 3 to the exponent n. So again, from the top half of the page, you know that if the variable is an exponent, then we have an exponential function, and therefore we must have a geometric sequence. So first 3 terms, t1, 3 to the power of 1, so 3. This is really the same as a, okay? Second term, 3 squared, 9. Third term, 3 cubed, 27. So 3, 9, 27, first 3 terms in the sequence. Now this last example, find the 15th term in the sequence f of n equals 2n squared minus 1. F of n is just function notation, same thing as writing t subscript n. If you notice, this time there's an exponent of 2 on the variable base. This is a quadratic relation. A quadratic relation is not arithmetic nor geometric. And sometimes we can have sequences like that. That's okay. So that doesn't stop us from finding the 15th term. All we need to do is sub in 15 for n. So 2, 15 squared minus 1, 2, 225 minus 1. And that gives us 449 as the 15th term. All right, moving on to the top of page 3. The second question type, to determine the general term of a sequence. And you have to be given at least 2 terms in order to do this. So find the general term of means determine the formula. So determine either the arithmetic sequence general formula or the geometric sequence general formula, or possibly a totally different formula, neither arithmetic nor geometric, and we'll go over an example like that. First off, if you're given 2 terms in an arithmetic sequence, first of all, you want to determine the common difference d between the terms. If you're given the terms that are consecutive, then that's really easy to do. All you need to do is subtract the previous term from the next term, so t2 minus t1 or t3 minus t2, that will give you the common difference. But what if you're not given 2 terms that are next to each other, but there are some terms in between them? So let's say you're given tc and th, then in order to find the common difference d, you are going to subtract those 2 terms, th minus tc, and divide by the number of terms in between them. So for example, if you know the 4th term and the 11th term, in order to find the common difference, you're going to take the 11th term, subtract the 4th term, and you're going to divide by 11 minus 4. Once you've done that, you can use the common difference and one of the given terms to determine the initial value a. So let's go over this example. Given the 3rd term as 17 and the 8th term as 37. This means that the 3rd term being 17 and then the 8th term being 37, there are 1, 2, 3, 4, 5 skips in between those terms. So you've added d 5 times. So take t8, subtract t3, divide by 8 minus 3, or 5 skips. So 37 minus 17 divided by 5. That gives us 20 over 5, which is 4. And I'm out of time, so go on to the next video.